Well, so far we've talked a lot about how Python works, but we haven't done a whole lot that's useful. Okay, until we figure out how to do repetitive programming, all we've got is a desk calculator. So we'll talk about the if statement, and if statement is a good time to introduce a really strange statement, but it's a useful one. We'll talk about two different ways that you can do looping. And interestingly enough, that's pretty much all the ways you can do looping. That'll probably take us through what we're going to cover today. So, all right. So, if statements. You saw one by accident earlier. The if statement has, you say if followed by a value of some sort or an expression, and if that evaluates to be true, then you provide it with a group of statements to do. And so what we've done is we've tested here, if A is greater than 0, then it's got a statement, print positive. It sets B equal to positive. And then it's got another statement here, test done. How does it know what statements are part of the if statement and what statements aren't? It looks at the indentation. Okay? So these two statements will be done only if A is positive. This statement will be done always. The indentation for these two statements needs to be the same so that they're recognized as being part of the same block of statements. If I use 3 spaces here, I better use 3 spaces there. Okay? If I use a tab here, I better use a tab there. Okay? If you use a tab in one and not the other, you're in trouble. Okay? This is why I told you typing Python programs in Notepad gets real tiresome really fast. Because it's really hard to tell whether you've got 7 spaces or 8 spaces. But if you're working with an editor that recognizes Python, it's going to automatically line this up with the previous one. So you don't have to worry about those things. Okay, if A is a variable, then I can test if the variable is true or false. Well, that works fine if it's a Boolean, but what happens if my variable is an int, for example? Well, for an int, 0 turns out to be false, and everything else is, actually, yeah, the first thing I should have pointed out is that here I only have one statement to be done on my if statement. You can combine them on a single line. Official Python styling says don't do this. I do it all the time. I think for me it's very straightforward. If I just want to test something and do something simple, it's just easier to look at that in my mind, rather than having to do that. So you can write a one-line if statement if you want to. But anyway, this will print true if I have an int in A and it's anything other than 0, or if it's a float and it's anything other than 0. If A is a string, tuple, list, or so on, empty is false, and anything non-empty, anything having a length of 1 or greater, is going to test as true. And none is always false. Okay. So we can also, yeah, question.
If I do if a colon whatever, open paren, can I get away with murder as far as the indentation then?
No. No. Paren is only used inside expressions. Yeah, no. There are other languages that do that. Python isn't one of them. It does not use, a paren is only going to be used inside a single line. There's another question. Yes, yeah. if I indent this one further, Python is going to come back and say, I don't know how to interpret this, because there's no way to start a new block of statements after a print statement. So why are you starting a new block of statements? It doesn't make any sense. There's no if statement or looping statement or anything like that that would lead me to know that I need a new block of statements. So it just gets, the interpreter will just get confused, and it will tell you I'm confused, and it will give up. Yeah. Don't. Don't. Okay. Yeah, I think you can do it with semicolon, but don't. Pretend I didn't say that. It's really bad. It's a really bad programming thing in Python to do that. More questions? I thought yes.
So if you have a long expression,
right.
Where does the indentation go?
It doesn't matter actually. The continuation line, it doesn't matter. It's only the beginning of the statement where it matters. So if I had, if what's that?
You also indent the expression.
When I do it, I will tend to indent it to make it more clear what's going on. And if I have a complicated bit of mathematics with multiple parentheses, I may use some indentation to help me figure out what part of the, what part of the expression I'm adding to and stuff like that. So the interpreter doesn't care at that point, but I care. I want to make my code easy for me to read because I know that I'm going to look at it later and I'm going to be completely confused. I think the professional term for that is gobsmacked. Gobsmacked. Okay. All right. More questions? Thought I saw somebody with their hand up before, but all right. Okay. If you have a if statement, you can have if and then else. So here I test if a is greater than 0 and I print positive, else I print negative or 0. And again, the lack of indentation means that this is going to be evaluated as the next statement after the if is done. Okay. The indentation here and the indentation there doesn't have to match, but it's a good idea if it does. You can also have multiple tests. So here, if it's positive, is it negative? And if it's not one of those, then I execute the else. So, I mean, if you've done any programming, you've seen something like this, but different mechanisms are used to designate the blocking of statements. And Python does it by using indentation, which makes the code really easy to read. And when it comes down to it, the most important thing about coding is not how quickly you can program, but how quickly you can change the program. Okay. Yes.
Are the else and elif statements required to begin at the same point as that?
Yes, they have to line up here. They all have to line up here. Yep. Yeah, if I had a space in front of it, Python would get confused because it would say, gee, this is not part of the same block as that. What's going on? And that brings us to something. What if I write something in such a way so that, I mean, you don't have to, you usually can find your way around it, but what if I set this test up and I don't have anything to do here? Well, it's expecting an indented line there. And if I just simply take that line out, and I've got if and elif, or if and else, one immediately after the other, again, the interpreter is going to get confused in terms of how the blocking works out. And so I have to put a statement in here. So Python gives us a statement that does nothing. Maybe it comes from Bridge. I'm not sure. It's pass. So this is a statement that does nothing. Why would I possibly want to code like this? Well, this might be a place where I want to put some code in later. Okay. I find that I use paths quite a bit, even though it doesn't seem like it's a very useful thing. Okay, so this is sort of logical, but I want to make sure you understand it. The indentation dictates grouping. So, oops, I didn't want to do that. Okay, so here I have an if statement and I have an else statement. And I have inside my if statement, I have another nested if statement. And this else is tied to this if because they have the same indentation level. If, on the other hand, I indent this else to line up with this statement, then now both of these are nested inside the if, and this is tied to that. Okay, so the indentation really matters, and that's why, in response to your question, the if and the else need to be lined up. Because otherwise you can't tell what if statement it's an else to. Okay. All right. So let's talk about looping. All right. The first example of looping is while, and while you have while followed by a expression that evaluates to true or false, and it will execute the statements following the while in the block as long as that tests as true. If this doesn't evaluate as true on the first try, the statements are never executed. If this executes, if I forget to increment t here, then this will loop forever until I turn off the computer or kill the program. So t starts out as 0. I then increment t, and note that you'll never find this written as t equals t plus 1 by anybody who's been using Python for a while, because they'll write it as t plus equals 1. But I wanted to make sure you followed this. So t equals 0. That tests as this tests as true. T is less than 10. So t gets incremented here. I print t, so t will start out as 1. The last time through this loop, t is 9, and t is still, so 9 is still less than 10. That's true. It gets incremented. That gives me 10, and it prints 10. Next time through, goes over here is t less than 10, and the answer is false. So it will execute whatever line comes after my while statement. All right, and again, unlike some languages, the test is executed before any statements are done, so you can put a while statement that will in such a way so that it'll never get run if you don't want it to be. Question? Yes. Okay, let me come back to that. The question was, can you use a break statement to break the loop? And the short answer is yes. And where do you put the break? Anywhere you want to. Oh, indentation. The break is part of the loop. So the break would get line. Yeah. So here's sort of the answer, although it probably isn't exactly your answer. But anyway, let's do the continue statement first. Okay. Continue is a sign that don't do anything else for the rest of this loop. So when you get to continue, it means go back to my while. Okay, so we'll go through this loop, same thing as we did before, except now I've changed it to the plus equals. But if t equals 2 or t equals 3, execute a continue. So what happens is for when I go through this when I go through this and t is 1 here, it prints a 1. But when t is 2, it just goes right back there, but the loop continues. Okay, so this version will print out everything from 1 to 10 except for 2 and 3. If I had made that and, it it would have printed out 2 and 3 because t could never be both equal to 2 and 3. The break statement gets you out of the loop. So when I encounter a break statement, the loop is just simply, it will just simply stop. So here, when t is 5, it breaks. It doesn't go back to the while, it just goes on to the next line. So this will print out 1 through 4. When t is 5, it will then go on and print loop done. Okay. Let's see. What do you mean? I could put it. Yeah, you could just have a line continue and break, and I could put it directly into the loop. Is that what you're saying? Oh yeah, I could have indented these. Yes, they did not need to be one-line statements, and specifically they're one-line statements because the room on one of these slides is small, so I'm trying to make my examples fit. But that might be a case where I would have, where I might have broken them up just to make it a little easier to follow the logic. So it would be perfectly legitimate. Yes, question.
While colon's legal, it can require a break.
Excuse me?
While is a colon with no test, is that a legal one?
No, I don't think so. I think it needs a value there. I don't think you can say while colon. Yeah, I didn't emphasize the colon enough. The colon is an essential part of that statement. And I do not believe while will work without a value there. You can say while 1, and that'll go on forever, and that'll go on. Well, it'll go on until you put a break in. So that's a very legitimate way to program. While 1, you know, and then some test and a break. Just better be sure that that test is actually going to come out true sometime. Yes. Mm-hmm.
If I understand all that right,
Mm-hmm.
every time this loop executes the actual memory location
Of teaching, right?
thing t points to
Mm-hmm.
change.
That's correct. That's correct. Every time this runs, we are effectively creating a new t and reclaiming and in a new place in memory and marking the old t as being available as being no longer needed. Okay. All right. Okay. This one is weird. And once you get used to it, you'll find even though it's weird, you'll use it. You can have an else statement as part of a while. Weird, yeah. What does that mean? The contents of else only gets executed if you don't encounter a break. Okay, so why do you use that? Well, it turns out it's not uncommon for when you use a break, you want to get the hell out of there. Okay, but if you've gone through the whole loop, you want to do something special. So you can do that in other ways, but this is a very neat, easy to read way to do it. So the so this writes a nice little. This is a nice little routine. It will print from 1 to either S or 1 to 9 because because it'll stop here. But if it stops the loop on this test rather than on that one, then it'll also print out that statement. So it turns out this is not something that you have to have in the programming. There are other ways of doing the same thing, but it's a very compact way to do this. Okay. There's another way to do looping, and that's with for. And the syntax is for some variable in something, and it turns out at some point much later we'll talk about iterators this is something that just simply has to evaluate to a bunch of values. So what this is going to do is it's going to assign x first to be 2, then to 4, and then to 6. So this will print out on one line 2, next line 4 as a string, and then 6.0 on the third line. And you can use continue, break, or else exactly the same way we did with while. This turns out to be a really useful construct because it allows us to iterate over lists and tuples and strings and things like that. Okay, and it turns out it's also really nice for dicts. Okay. Oh, sure, please, yes. I'll answer your question, but I'll get to your question in a little bit. That's I think the last thing I'm going to show is how to do that. So, okay, so if you have a dictionary, here's my dictionary. If I loop over my dictionary, I will get the keys in this dictionary. So the keys here are 2, again 4, and 6. So for key in D, I will get, and you'll notice, 4, 2, 6. Not the order I specified them in. If I run it again, I might get a different order. Yes? Is key a reserved word? No. No, it's not. It wouldn't have taken it if it was. Let's see. If I want to control the sequence that I want to access the keys, I can sort them. So here's a place where I've sorted them. And here I've referenced both the key and the value associated with the key. Turns out there are other ways of doing that as well, but this is a good one for right now.
So in the upper example, the word key there is not a keyword, it's just a name.
It's just a value. It's just a variable. I could have used...
So if you iterate on a dictionary and you don't tell it anything else, you are iterating on the key.
Correct. Correct. I could put anything there. I could have put K. I could have put my var. This is just the name of a variable. It's not a keyword here. That was probably a bad choice. Okay. So let's see. Okay. Now the question in the back a moment ago was, what if you want to do a loop over a certain number of numbers? And for that, we have something called range. What range does is it creates a tuple. And the range command, as used here, will create a tuple of 0 through 4, 5 numbers. Okay, so here I've iterated over 0 through 4, and it'll print 0 through 4. Okay, what if I want to? So here I've just told you. Actually, I guess it generates a list rather than a tuple. I can also go over a range, so I can specify a starting value, and I can also specify an increment. So here I'm going from 2 to 9 in steps of 2. Here I'm going from 2 to -2 in steps of -1. Okay, range only works with integers, but there is something else called xrange that allows you to do step and to do the same thing with floats. No, that wouldn't make any sense, because if you want to do every other key, that implies you know something about the ordering of the keys. Okay, so, I'm sorry, I can't. Sure, absolutely you can do that. But if you think about what you're doing, So, okay, the question was, what about if I sort them and then I want every other one? Can I do that? And the answer is absolutely yes, but not quite the way you're thinking. Because when I've taken my list of keys, I have made a list out of it. Okay? Then I can sort it. That's still a list. And now I can stride it. I can index every second element, and that's yet a new list. And now I'm iterating over a list. So the answer is yes, you can do what you want to do, but it's not exactly what you're thinking about. It's not, you're no longer iterating over a dictionary, you're iterating over a list, but you can use those as keys to get back into your dictionary. Okay. And, oh yes, another question.
With all these different loops,
Mm-hmm.
loop is done, T in your while example, or X or I.
Right.
Do these variables still exist?
Yes. 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 I will exist when this is done, and it will be equal to 4.
And if it breaks, then it has the value
At the time of the break. Yep. So here, let's go to the one that's easier to follow. Here, when this is done, T will be 10 because it has it will print 10. T will be 10. It will come back here. It'll do the test. It fails the test, and it just continues. Yes. Mm-hmm. You do not need to define your variable before. So X can be a new variable, can be an old variable. It'll just simply be overwritten. It'll be reused. Yes, if you look at my code, you will see a whole lot of for item in this or for I in this or something like that. It doesn't have to be a new variable. But it doesn't go away either until you're, until you do something like exit from a routine or something like that. Okay. All right. What if I have a bunch of stuff and I want to iterate over all of these things at the same time? I have 3 lists, A, B, C, 11, 12, 11, 22, 23, and my last list is 0 to 4. And I want to loop, and I want to send one variable to one thing and another variable. So I want to go through this list, and I want to get A first, and 11, and the first element in range, which is 0. And then I want to go back and get B and 22 and the second element in my range, and then the third element in my range. How do I do that? Okay, this is where the zip command comes in. And what zip does is it takes a bunch of either tuples or lists, and it makes a new list with a tuple coming from the first element, the second element, and the third element, and so on. Now I intentionally used range here because that's got 5 elements in here. It only goes until it runs out on the first. So that's why I ended up with 3 things here. Okay, so it only goes to the shortest input item. Now this allows me to do something fairly complicated. So here I'm iterating over I, J, K. I, J, K here is a tuple without parentheses. Probably would have been better if I put them in there, but it works exactly the same. And I'm going to iterate over this. So I, J, and K get assigned first to the 3 elements of the first tuple. So I, J, K in the beginning, I will be A, J will be 11, and K will be 0. So if I print it, so I is A, and J plus K is 11, since the first value is 0. When I go through this the second time, J is going to be 22, but the value from the range is going to be 1, so that's why I get 23. So this is a way that you can use a for loop on a bunch of collections at the same time. Yeah?
All right. Once you assign a tuple, you can't change an element in the tuple,
Mm-hmm.
but you can rewrite the entire tuple.
Say this again. Once you've, yes,
Couple that's 1, 2, 3, and then reassign 4, 5, 6 to it, because that's what it looks like it's doing.
it's created an it has rearranged this so that all of these as long as these things are not compound, then I don't have to worry about my aliasing problem. That's what you're asking. I've created new objects. But if this, if for example A were a list, then it would just simply copy a reference to that list.
I was worried about the fact that originally tuples were not changeable.
I haven't changed it. I have copied elements out of it. Yes? I'd get exactly this. I still get 3 items because it's going to go over this, and this has length 3, and this has length 3. So it's just going to go as far as the shortest list. Okay? So if this one were only A and B and there was no C here, then it would give me back something with 2 elements because it would run out at that point. Question in the back? Okay, I have defined a tuple here. The tuple is ijk. That's a tuple, right? That's a tuple. I could have put parentheses there to make it more clear, and it would. And it's the only reason I didn't is because this is such a common syntax. But what's going on here is I have a tuple of length 3, and this creates a list of tuples. And the tuples that it creates better be length 3. If somehow I had an expression here and it evaluated to a tuple of length 4, this would fail because it can't assign 4 values into 3. Okay. All right. So ending just right on time here. Homework. Okay, so we're actually ready to do a little bit of math. So using a while loop, calculate a factorial, and with a for loop, calculate a factorial. Okay, all right.